All right, guys. So so let you know a little bit here about tomorrow's quiz. I think I told you this yesterday, but I will reiterate. Tomorrow's quiz. Okay, you have 10 questions. Okay, they're all prediction. And the first 5 are going to be, I give you the reaction in formula form. So you'd get like K plus Cl2. And then the expectation is then that you will complete so you'll predict the products, right? So, okay, it's KCl, and then you will balance the reaction. So, okay, I've got to put a 2 here and a 2 there, right? You wouldn't have to rewrite it or anything. Okay, you're just predicting the products. And then the second set, I give you the reactants out in words. So, like magnesium reacts with sodium chloride. Okay, and then you would have to go, all right, that means Mg reacts with NaCl, and then you would predict the products and balance. Okay, that's what you're going to have tomorrow. Everybody with me there? Okay, so what we're going to work on today, this will be the last day where we practice and do worksheets on reactions, because we'll have our quiz on reactions tomorrow, give you the assignment on reactions on Monday. Okay, and you'll get the whole class to work on it on Monday. Also, a reminder that your lab report on reactions is also due on Monday. Okay, so make sure that that's submitted for 8:30 a.m. Monday morning. Okay, everybody clear on that stuff? All right, so this is the last sheet, I believe, in your booklet. We were working on the booklet yesterday, and we got, so like number 20 there. Okay, and then it starts right down here. Okay, so these are the same questions right here that are on the board. These ones are easier, right? These don't require the prediction, they're just writing it out. But we will get to, before the end of class, the last bunch here from 17 to 24. Those are prediction, but we'll do some of the just written stuff before that. So if you can get started on, I'll eventually find it here. Okay, that question there, so the CuF2 plus Na, okay, get started on those. You're just identifying the type, writing it out in words, and balancing it. Okay, same as we were working on before. We'll go through a few of those just to make sure everybody still understands what we're doing there. And then we'll move on to the prediction stuff, and that's probably as far as we'll get today because we have a slightly shorter class than usual because of maths this morning. All right, so you guys can get to work on that. Okay, that's the booklet I gave you the other day. Okay, I see a few people have gotten as far as the one with chromium here, okay, number 11. If you've gotten that far, there's a mistake on the sheet. What's missing from chromium sulfide? A Roman numeral. Chromium can be a 2 or a 3, and it isn't indicated here, okay? So this is chromium with the Roman numeral 3, okay? It's just missing for whatever reason. So if you get to that one, just make sure that you know that's chromium 3 sulfide when you get there. Okay, let's look at the first few on here. So for number 1, I've got an ionic compound reacting with an element, getting a new ionic compound, new element. What kind of reaction are we looking at? Single replacement. Okay, so that's the first thing. And of course, if we were predicting, that is something we would have to be able to identify with just the reactants. Okay, I've got to balance this thing. Right now, the fluorine is out of balance, so I'll need to put a 2 here. Okay, it's also the biggest number. When I put the 2 in front of that, I will also have to put a 2 here in front of sodium, and then the rest of the reaction is balanced. If I'm writing this out in words, what do I have to remember about copper? It needs a Roman numeral because it can be a 1 or a 2. Since fluorine is always -1 and there are 2 fluorines, this must be the copper with the 2+ charge. Okay, so this is copper 2 fluoride. Okay, and it's reacting with sodium, and that is going to produce sodium fluoride and copper. Does copper need a Roman numeral on this side? It does not, because in its element form, its protons and electrons are balanced. It doesn't have a charge. All right, so that's what that one should look like. All right, for number 2, I've got an element reacting with an element. What kind of reaction starts that way? Synthesis. Okay, so they're going together to form this single ionic compound. If I'm going to balance this, 4 is my biggest number, so I would need to put a 2 there to balance my phosphorus, which gives me 6 berylliums. So 6, 1, 2 would be the balancing numbers there. And then we would have beryllium plus phosphorus, okay, is going to give us beryllium phosphide. Okay, no Roman numerals or prefixes needed there. Okay, number 3. My reactant is one single compound. What's the only type that starts with one reactant? Decomposition. Okay, so in this decomposition reaction, okay, I've got carbon tetrachloride. Have we had a lot of reactions with molecular elements in them lately? Okay, so something to be on the lookout for, right? We got to remember, I got to use prefixes here, okay, things like that. So carbon tetrachloride is going to break down into carbon and chlorine. And then if I'm balancing, 4 is the biggest number. A 2 there takes care of the chlorines. Okay, questions on that one? Okay, and number 4. Got ionic compound reacting with ionic compound. What's the only reaction type that starts that way? Double replacement, yep. Okay, so the pattern in a double replacement reaction is that all that's going to happen is the metals are going to switch partners, which we can see is exactly what happens here. If I want to balance this, 2 is my biggest number, so I'll balance my hydrogens and my bromines with that number, and that is all that reaction would require. To be balanced. And then we would have in words, because this is an ionic compound, hydrogen bromide plus barium sulfide gives us hydrogen sulfide and barium bromide. Tomorrow, do you need to check? Well, I guess you're not going to be writing much in words, so you don't have to check spelling. But, okay, make sure that we're checking everything like charges and stuff like that. All right, then for number 5, okay, I've got an ionic compound reacting with an element. What kind of reaction starts that way? Single replacement. All right, in a single replacement reaction, all that's happening is the thing that's the element is going to swap out the part that it's like. So silver's a metal, it's swapping out iron, and we got to balance this thing. 3 is the biggest number, so a 3 there will balance my oxygens, but it will give me 6 silver, and I've got to put 2 iron over there to make the rest work. Okay, what do I need to remember about iron when I write out this name? It needs Roman numerals. Okay, it can be a 2 or a 3. Oxygen's always a -2. That gives me 6 negative charges. So I've got to get 6 positive charges out of 2 irons. 6 divided by 2. This is iron Roman numeral 3 oxide, and it is reacting with silver. And that is going to produce silver oxide, also known as tarnish. If you have ever had silver tarnish, that is what it is, silver oxide. Okay, and iron. Do I need a Roman numeral on the iron? No, it's by itself. Okay, what kind of reaction is number 6? Combustion reaction, yeah. Okay, so obviously I wouldn't give you one on a test where you had to write the name if it was beyond the prefix of 10, but this stuff is called hexane. Okay, and it is reacting with oxygen, and that is going to produce carbon dioxide and water, as all combustion reactions do. And then in this one, we have 2 special balancing rules. Do I need them both? Yes, 6 is an even number, so I've got to start with a 2 Okay, and then I balance alphabetically. 2 times 6 is 12, so I put a 12 there. 2 times 14 is 28. So 14 needs to go there, and then I can add up my oxygens. 12 times 2 is 24, plus 14 more is 38. 19 times 2 would give me 38. So big numbers on that. All right, and then on number 7, I think that one was on the board as well, right? So in this one here, I've got cobalt and selenium. These are all, that shouldn't be a negative. Okay, these are all ionic compounds. So what kind of reaction is that? Double replacement. Okay, so if I'm doing that one, I would have, what do I need to remember about cobalt here? Right, it needs Roman numerals. Selenium's a -2, so this must be the cobalt that is the 2+ charge. And it is with it's reacting, sorry, with manganese. Does that also need Roman numerals? It does, because it can be a 2 or a 4. Okay, since iodine's always a -1, that gives me 4 negative charges. There's only one manganese here, so it must be manganese IV. Iodide. Okay, now, since I did all that work, do I get to keep all that work for the other side? Yeah, copper and no multivalent metal is going to change charges in a reaction. If it was Roman numeral 2 in the reactants, it's Roman numeral 2 in the products. Okay, so we would have cobalt, Roman numeral 2, iodide, I don't need to do the calculations again, plus manganese for selenide. Oh, I forgot to finish that. This would be cobalt 2 selenide. I forgot to finish that. Okay. Questions on those? All right. How many people are... oh, sorry. We didn't do 8. How many people are done 8? Okay. I'm going to give you a few more minutes on 8, 9, 10 here. I'll put those ones up. Okay. And we'll go through 8, 9, and 10 here in a couple minutes. Okay, so for number 8, the reason I put one on like number 8 is because sometimes when I use ammonium as one of the ions, it throws people off as to it being an ionic versus a molecular compound because they see something that starts with a non-metal. Okay, in the case of this, what kind of reaction is this? It's a single replacement reaction because ammonium chloride is an ionic compound. But again, it starts with a non-metal. Sometimes it throws people off. Okay, that's why I put one up there like that. But you guys weren't fooled. It's a single replacement reaction. Okay, if we're writing it out in words, this is ammonium chloride. Okay, it's reacting with sulfur. Okay, and that is going to make ammonium sulfide. And chlorine. Okay, if I'm going to balance that, probably start with the 8. It's the biggest number. So I would need to put an 8 in front of the ammonium sulfide. That's going to give me 16 ammonium. So I'm going to have to put a 16 in front of that. That's going to give me 16 chlorines. So I would need an 8 in front of that. So we'd have 16, 1, 8, 8 for our balancing numbers for that. Okay. All right. I feel like I've put number 9 on here about 4 different times. Okay, that we've seen magnesium react with nitrogen gas. But why do I keep putting it on there? Nitrogen is special, and we got to remember that. Okay, and that is going to produce magnesium nitride, which is an ionic compound that needs to be dropped and swapped. So we got a -3 and a +2, so Mg3N2 for that one. Okay, and then 3 is our biggest number. 2 is already balanced, so I'm just going to go over here and put a 3 there, and everything else should be a 1. All right, and then for number 10, we have beryllium oxide, so Be with O. So that's a -2 and a +2, so that one's okay, dropped and swapped. Okay, and it breaks down. All right, if it's breaking down, what kind of reaction is that? It's a decomposition reaction, right? Okay, into beryllium and oxygen. What do I need to remember about oxygen? That it's special, because it's a 2. Okay, now that I've got that done, now I can just balance. A 2 there balances my oxygens. A 2 there balances my berylliums. 2, 2, 1. Okay. All right, keep going there, guys. I'll go over 11 through 16 here in a couple more minutes. And then we'll move on to the predicting ones. All right, guys, let's look at a few more of these ones here. So this was the one we were talking about earlier that needed a Roman numeral but didn't have it. Okay, so chromium 3 sulfide. So that's the 3 plus chromium with sulfur, which is a -2. So Cr2S3 would be our properly dropped and swapped ionic compound there. It is reacting with copper metal. Okay, now if this was a predicting one, I would have to go with copper's most common charge on the other side, but in this one it's not predicting. It's telling us, okay, that on this side it is copper with the 2 plus charge going with sulfur. It also has a 2 minus charge, so that compound is fine that way. Okay, and chromium metal. Okay, so just Cr. Okay, if I'm going to reaction type there, what kind of reaction are we looking at? Single replacement. I got an ionic compound and an element. Okay, so when we do that, now we've got to balance this thing. Sulfur is the biggest number. I need to put a 3 there to balance the sulfur, a 3 there to balance the copper, and a 2 there to balance my chromiums, and then this would just be a 1. Okay, for number 12, we got silver nitrate. Okay, so Ag plus 1, nitrate minus 1, so that compound's fine the way I wrote it, with potassium fluoride. So K plus 1, fluoride minus 1, so that compound's also fine the way I wrote it. Okay, and that's going to produce silver fluoride plus 1 minus 1, so that compound's fine the way I wrote it. Okay, and potassium nitrate, K with a plus 1, nitrate with a minus 1, also fine the way I wrote it. Okay, what kind of reaction is that? Double replacement, everything's ionic. Do I have to do anything else to it? Everything at a charge of plus 1 or minus 1, so everything is already balanced in that reaction. Okay, number 13, tricarbon octahydride. Okay, so C3H8, or propane, burns in the presence of oxygen to produce CO2 and water. What kind of reaction are we looking at if the word burns is in there? Combustion reaction is kind of a giveaway. All right, do I need both balancing rules for this one? No, 3 is an odd number. I only use the rule of 2 with even carbon numbers. Okay, so now alphabetically, 3 carbons, 8 hydrogens, 4 times 2 is 8. Now that I've got my numbers, I can do oxygen. 4 times 1 is 4, 3 times 2 is 6. Okay, 6 plus 4 oxygens is 10. 5 times 2 is 10. Okay. All right, for 14, nickel 2 phosphide. So we got Ni with the 2 plus charge. It is going with phosphide, which is a -3, so we'll have Ni3P2. Okay, and it reacts with just bromine, which is a special element, so I need to put Br2. And that is going to produce nickel 2 bromide. All right, so Ni plus 2, bromine minus 1, so NiBr2, okay, and phosphorus. What do I need to remember about phosphorus? It's special. It comes as a 4. Not one we do as often, okay? That's why I put it on there. Really a reminder. Sulfur we do all the time. It's an 8. Phosphorus less often. It's a 4. Okay, now what kind of reaction are we looking at? Single replacement. Ionic compound plus an element. Okay, biggest number is 4 for balancing, so we'll start with phosphorus. 4 in the products, Now, 4 in the reactants. That gives us 6 nickel, so I'll need a 6 there to balance the nickel. That gives me 12 bromines, so I'll also need a 6 there, and then that would be a 1. Okay, for 15, nitrogen gas, N2, reacts with oxygen gas, also special, O2, to produce dinitrogen and 2 trioxide, O3. What kind of reaction is that? Synthesis. Okay. I need to balance this. I got a 3 as my biggest number over here, so lowest common denominator, or lowest common multiple, sorry, is 6. So I need a 3 there, and then a 2 there to balance my nitrogens. Okay. And then the last one in this set, we got rubidium sulfide. So rubidium is Rb. It's a +1. It's with sulfur, which is a -2. So we need Rb2s. Okay, it's reacting with zinc nitride. All right, so Zn, that's a 2+. Nitrogen is a -3, so Zn3N2. Okay. To produce rubidium nitride, so Rb +1 with nitrogen -3, so Rb3N, and zinc sulfide, Zn, that's a +2, S, that's a -2, so that compound's fine, 1 to 1. What kind of reaction is that? Double replacement. I had to drop and swap every single compound, so they were all ionic. Okay, now biggest number there is 3. It's on both the zinc and the rubidium, but zinc has a bigger charge, so we'll start with that. 3 zinc, okay, 3 zinc. When I do that, I get 3 sulfur. So I got to come over here, make sure I have 3 sulfur. That gives me 6 rubidium. So if I put a 2 there, that gives me 6 rubidium and 2 nitrogens. There's 2 nitrogens here, so we're good. Okay. All right, keep going on the last set there, guys, where you are predicting the products, 17 through 24. I can't get them all on the screen, but hey, we'll do 2 or 3 here in a couple minutes. All right, so for number 17, we have calcium, and it's reacting with oxygen. What do I have to remember about oxygen? Special, O2. Okay, what kind of reaction are we looking at? Synthesis, yeah, we just have 2 elements, okay, that are reacting here according to the pattern. That means that they will combine to form a single compound. What kind of compound did I just make?
Calcium oxide.
I made calcium oxide, ionic compound, right? So what do I have to check? Drop and swap. I got to make sure that I did in fact make this the right way, and I did. So it's fine the way I wrote it. All right, now I got to balance the reaction. There's 2 oxygens here, so a 2 there balances my oxygens, a 2 there fixes the calcium. We would have 2, 1, 2 for that. Okay, the synthesis ones are obviously pretty straightforward. Okay, for number 18, rubidium nitrate. Okay, so we got rubidium, that's a +1. It's with nitrate, that's a -1. So that compound's fine the way I wrote it. Okay, and it's reacting with copper metal. Okay, what kind of reaction am I looking at there? Single replacement. Okay, in a single replacement reaction, the pattern says this element swaps out the part of the ionic compound that it's like. Copper is a metal, so rubidium is going to wind up by itself being swapped out by copper. So copper is going to wind up with nitrate. But they never told me what copper it is. Okay, because they didn't have to. On that side, copper was an element and had no charge. Since I have no way to figure it out, I go by the first one, the most common charge, which for copper is 2. Okay, so this is copper with the 2+ charge. Okay, it's with nitrate, that's a -1 charge, so I'll need brackets with a 2. Okay, it's not a rule that comes up very often, but since tomorrow is your last quiz on reaction, should you expect a few exceptions in the questions? Yeah, okay, expect something like that would probably come up. Okay, some of the other exceptions that we've talked about would also be fair game. All right, now that that's done, I need to balance the whole reaction. Nitrate's 2 on the products, so I need a 2 here, and then a 2 in front of the rubidium. Everything else would be a 1. Okay, and then for 19, iron metal. Fe. Okay, reacts with hydrogen hydroxide, water. Okay, what kind of reaction is that? Single replacement, yeah, because I wrote water like an ionic compound. This is actually part of the rusting process of iron. Okay? So what I'm going to be left with here is hydrogen gas. I have to remember that that's a special element. And I'm going to have iron with hydroxide because it's got to swap out the metal. Is this the same idea as the last question? They didn't tell me which iron this was, so I have to go with iron's most common charge, which is 3. Yeah. Okay, so when I drop and swap this one, I will have FeOH3. So iron 3 hydroxide, and now I can balance the reaction. So I've got 3 hydroxides, but if I just put a 3 here, I can see I'm going to have a problem with that hydrogen. What's the lowest common multiple of 2 and 3? 6. Okay, so I'm going to put a 6 here, a 3 there, and 2 there. That should balance all the hydrogens and hydroxides, and then a 2 there should balance the iron. Okay, the tricky part of that one is actually the balance. All right, I will give you guys a few minutes. 24 is now on the board in case you lost your sheet. Okay, and we'll go over those in about another 3 or 4 minutes. Okay, let's have a look at a couple more of these here. So for number 20, I've got methane, which is CH4, okay, is burning in oxygen gas. All right, if it's burning, what kind of a reaction is it? Okay, what are always the products of that? CO2. Good, okay. Special balancing rules. Do I need them both? I do not. 1 is an odd number, and that's what we have here, 1 carbon. So I can just go straight to balancing in alphabetical order. 1 carbon, 1 carbon. 4 hydrogens, 2 times 2 is 4 hydrogens. Now I can do the oxygens. I have 2 here, plus another 2 for 4. 2 times 2 is 4, and I'm done with that one. Okay. Okay, for 21, sodium sulfide. All right, so that's a +1. Sulfur is a -2. So we'd have Na2S, and it just says that it breaks down. What kind of reaction is that? Decomposition. Okay, the pattern for that is that the atoms are separated. Na plus S. What do I always need to check for in decomposition reaction? Special elements. Okay, this one's special, this one is not. Okay, then I can balance. 8 sulfur on that side, I need 8 sulfur on this side, and then I would need 16 sodiums in the products. So 8, 16, 1 for that. Okay, for 22, magnesium, so Mg is with sulfate, SO4, that's a -2 and that's a +2, so that compound is fine the way I wrote it. Is reacting with potassium permanganate, K, that's a +1. Permanganate, MnO4, that's a -1. So that compound's also okay the way I wrote it. What kind of reaction would that be? That's a double replacement reaction. Pattern for that is swap the metals. So potassium will end up with sulfate. And magnesium will end up with permanganate. Okay, I just made 2 new ionic compounds. What do I have to do to both? Drop and swap. Okay, so this is a +1, that's a -2, K2SO4, and then we've got 2 plus, 1 minus, so this is going to need brackets to look like that. Okay, now I need to balance. 2's the biggest number, and I'm pretty sure if I put a 2 here, I fix everything in the reaction. There's 2 potassium and 2 permanganates on both sides now. Questions on any of those so far? All right, for number 23, I've got cesium fluoride, so another ionic compound. Let's go up there. Okay, cesium fluoride, so, whoop, not Ce, Cs for cesium, and that's a +1. It's with fluorine, that's a -1, so that compound's fine the way I wrote it. And it's with manganese 4 carbonate, so Mn with a 4+, and carbonate with a 2-. Okay, when I drop and swap, I'm going to get 2 and 4. Do I leave it that way? What do I take it down to? 1 and 2. Is that an exception that could appear on tomorrow's quiz? Yes. Okay. All right, so I'm going to have that. What kind of reaction is that? Double replacement. They're both ionic compounds. So swap the metals. Manganese ends up with fluorine. Cesium ends up with carbonate. I just made 2 ionic compounds, so I got to drop and swap them both. Okay, -2 and a +1, so I'll need a 2 there. And this was a +4 on the other side. This is a -1, so MnF4 for that. Then I've got a balance. 4 is my biggest number. So if I put a 4 there, my fluorines are balanced. That gives me 4 cesium. A 2 there will make my cesium work as well as my carbonate. And the rest of the reaction should be good. So 4, 1, 1, 2 for that. And then our last one, hydrogen chloride. HCl, that's a +1, that's a -1. Reacts with sodium hydroxide, NaOH, that's a -1, that's a +1, so that one's fine too. What kind of reaction is that? Double replacement. Okay, pattern says swap the metals. Okay, since everything was a 1 over here, everything's a 1 over there. Am I balanced? Okay. So, you know what's on tomorrow's quiz. If you are going to be looking to do all 4, great. 12 and 13 are most like what you're going to see tomorrow. Each one of them is a 5-question prediction quiz. 10 and 11 have other reaction stuff on them as well. Okay, so have a look over those tonight. Lab reports due on Monday, and I put the date of your unit exam for chemistry up. It's still a long way away, okay, but it is set as October the 9th. All right, we'll be starting the mole equation on Wednesday of next week. Okay, that'll take us 4 days, 5 days tops. We'll have a unit exam review period, and I will post a unit exam review package late next week-ish. Okay, so that you can start kind of having a look at it. Once I've taught you the mole, you'll know how to do everything that will be on the test. Okay, all of that's coming up. Make sure it gets in your calendars.